element will change its electronic configuration to be stabilized. Okay, how it will be stabilized? By having 8 electrons in its outermost shell. Okay, we have already discussed by taking an example of sodium chloride, and I have also given you the task to do for magnesium oxide, and most of you have done also. So later on in next topic we will have some more discussion on electronic configuration. So don't have a confusion for this topic, and just remember electronic configuration means the arrangement of electrons, okay, on the cells or on the orbits. And when a chemical reaction takes place, the elements undergo change in their electronic configuration to form a stable configuration. Okay, so today we will move on to the next topic, which is very much important. Just listen all the topic very carefully. Okay, so today we will discuss the conditions necessary for a chemical reaction. Already we have discussed in a chemical reaction we got reactants and products. Okay, reactants may be 2 or more than 2, products may be 2 or more than 2. If you will take the example of sodium chloride, sodium and chlorine will be the reactant and sodium chloride will be the product. If you will take the example of water, hydrogen and oxygen will be the reactant, who both will react to form the product water. Okay, so for a chemical reaction some conditions are very necessary. Just in simple way a chemical reaction cannot take place. Okay, when a chemical reaction is taking place, it should satisfy some of the condition, and the conditions will vary from different reaction to reaction. The conditions will not be same for all the chemical reactions. So let us discuss all the conditions that are necessary for different chemical reactions. Okay, so the first one is close contact. The two reactants should be in a close contact when they are reacting. So just take the example, in the last video we have discussed about the electronic configuration of sodium and chlorine, so that they can form the sodium chloride. So there we have observed that one of the electron from the valenced cell, if I will just give you a short, okay, here I am doing only the outermost cell. Okay, there is a single electron in the outermost shell of sodium, and if we will talk about chlorine, then in the outermost shell of chlorine it got how many electrons? It got 7 electrons. Okay, so that when both the sodium and chlorine they will be placed close to each other, sodium can donate 1 electron to chlorine to satisfy the octet rule. By donating 1 electron, sodium will also be stabilized and chlorine will also be stabilized, and in turn they will form a product sodium chloride. Okay, so here the my object to tell you about the example is that whenever a reaction is taking place, the reactants should not be far apart from each other. They should be in close contact so that the transfer of electron will be easier. Okay, and they will have a good chemical reaction. They can undergo the chemical reaction in very effective manner. Okay, this is only known as close contact. Whenever a reaction is taking place, the element should be in close, or the reactants should be in close contact. These are the reactants and this is the product. So the reactants should be close to each other so that the transfer of electron will be easier and we can get the product. So here one more example also we can take sodium and water. Sodium, actually when in laboratories, sodium, in lab, sodium is kept inside kerosene because sodium reacts very vigorously with water. It produces a burning effect, it produces a blasting effect. That's why in laboratories, to avoid this, explosion, sodium is kept inside kerosene so that it cannot be in contact. It cannot be able to be in contact with water. So sodium when comes in contact with water, it forms a explosive reaction. Okay, so that's why sodium and water, we can here take the example of close contact. When sodium and water kept closer to each other, they form a reaction, and that reaction they can form a explosive reaction. Okay, next, solution form. Some reactants, after keeping them in close contact also, they cannot react, because they will only react in their solution form. Means we have to make it solution. We have to add water to that reactant and make it a solution, so that both the reactants can react. Okay, let us take an example and discuss. Here I have written sodium chloride reacts with lead nitrate to form lead chloride and sodium nitrate. Sodium chloride, if I will write the equation for it, sodium chloride plus lead nitrate, it will form lead chloride and sodium nitrate. It again need to be set the equation. Yes, okay, don't worry how to write the equation, how to arrange the equation, again how we can balance the equation, that all we will have in the next topic. I am not discussing that. Here I am just discussing the example with you. Sodium chloride when react with lead nitrate, here which all are the reactants? Sodium chloride is the reactant and lead nitrate is the reactant. When both the reactants, see here we have to mention in bracket, I am writing AQ. Can you say why I am writing AQ? Because they are in solution form, and solution form is also known as aqueous form. Aqueous means, aqua means what? Water. So here we have to mention in the bracket AQ. AQ means aqueous. Means NaCl should be in its solution form. It should be in its aqueous form. Means we will mix sodium chloride with water and we will mix lead nitrate with water, so that they can react with each other and they can form lead chloride and sodium nitrate. Okay, so this is the reaction for solution form. Solution form means some of the reactants, even if we will keep them closer to each other, they will not react in their dry form. They need to be in their solution form or in their aqueous form. That's why we need to add water to that reactant, and so that they can react in their aqueous form and they can produce or they can form a product. Okay, here you can note down the equation, it will be helpful for you. Next, heat. Another condition we can talk about, heat. Heat is also playing an important, or it is a very important factor during the chemical reaction. Some of the chemical reaction takes place in presence of heat. Like here I have given the example of iron and sulfur. Iron and sulfur, they undergo reaction in presence of heat to form iron sulfide. Okay, iron and sulfur in presence of heat. Heat can also be denoted as triangle. Okay, remember, FeS, iron sulfide. So iron and sulfur, one more example only I am giving. I am not going to more example. I am not going for more example, because till now we have not discussed the how to write the chemical equation, how to balance the chemical equation. That all, don't worry, don't have a confusion. I will discuss it one by one. Okay, here just one example as it is given in your book. Both the word equation and chemical equation I am writing. Okay, so heat is also playing an important role. Here we have taken the example of iron and sulfur. Iron and sulfur when reacts in presence of heat, it forms iron sulfide. Okay, next, light. Very simple example we can take, photosynthesis. Photosynthesis is also a chemical reaction which takes place in the presence of light. And I think I should not write, I should not go in details about the equation because already in our earlier classes also we have discussed about the equation of photosynthesis. What is the equation of photosynthesis? Is it 6 carbon dioxide, 6 water in presence of light and chlorophyll. In presence of light and chlorophyll, it forms glucose and it will release oxygen. So here the very simple example we can take photosynthesis. Photosynthesis is a chemical reaction where light is playing a very important role. Remember, without light photosynthesis cannot take place. Light is playing a very important role in photosynthesis. Okay. Next, pressure. Pressure is actually needed when the reactants are in gaseous state. Just remember this. Pressure is playing an important role for the chemical reactions where the reactants are in their gaseous form or gaseous state. Okay. So here we can take the example carbon monoxide and hydrogen. Carbon monoxide is also a gas. Hydrogen is also in its gaseous state. So we can take the example carbon monoxide. Here in bracket I am writing G. Small g means gas. Okay. For aqueous, here in bracket I have written small a and small q. Carbon monoxide plus hydrogen, it forms methanol. Okay. Balancing and all we can talk it later. So carbon monoxide and hydrogen in its gaseous state, it will form methanol. Okay. So this is in pressure. So when they are kept in high pressure, they will form methanol. Again, one example we can take water plus carbon dioxide. It forms carbonic acid. Okay. Here I am not balancing the equation because balancing we have not done. Do not waste the time by discussing the balancing and all. Later on in next topic we will discuss how to balance the equation, how to write the equation. Just now for as I am giving the example, I am discussing one by one word and chemical equation. So here two equations I have discussed. Carbon monoxide, it will react with hydrogen in high pressure and it will form methanol. Water, when it will react with carbon dioxide, it will form carbonic acid. And can you tell me where this example is applicable? In soft drinks. Okay. And when they form carbon monoxide gives a sour taste. That's why when you are taking soft drinks, it forms a sour taste to your mouth. Okay. Because carbon dioxide reacts with water to form carbon dioxide reacts with water to form carbonic acid. Got it? So here we can talk, here also I am writing pressure. Okay. So here pressure plays a very important role in these two reactions. One is for production of methanol, another is the formation of carbonic acid. So here both the cases they are in their gaseous form. Most often they are in their gaseous form. Okay. And when they are subjected to high pressure, that's why when we will open the soft drink, it will first it will come up in the form of gas, because the water and carbon dioxide they will be subjected in a high pressure. That's why they can react and they will form carbon monoxide. But remember, carbonic acid. But remember, carbonic acid is not good for our health. That's why avoid taking soft drinks, okay, or cold drinks. Now, electric current. Electric current is also needed for some of the chemical reactions. Okay. So see, as we have discussed, these conditions are not same for all the chemical reactions. Okay. some of the conditions. So let us discuss electric current. Electrolysis. Electrolysis is a reaction of, or we can say the breaking of water. Okay, when water breaks down, we call that reaction as electrolysis. Just remember, note it down. Electrolysis is a process of breaking down of water in the presence of electric current. Okay, so when water is subjected with electricity or electric current, it will break. Okay. Okay, so when water is subjected to electric current, it will break and it will divide to hydrogen and oxygen. Obviously, when we combine hydrogen and oxygen, it can form water. So when water will split or water will break, what it will form? It will form hydrogen and oxygen as a reactant. So here you can see this is the product and this is the reactant. In electrolysis process, the product will form the reactant. Okay. Next, catalyst. What is catalyst? Catalyst is a substance which speed up a chemical reaction. Just remember and note it down. Catalyst is a substance which speed up a chemical reaction without participating in the chemical reaction. Remember, it will not participate in the chemical reaction, rather it will only speed up the chemical reaction, that is known as catalyst. And here we have taken the example of nitrogen, hydrogen act or react in the presence of iron as a catalyst and form ammonia. Okay, here the catalyst is iron, means iron will speed up the chemical reaction. Iron will not participate in the reaction, it will not act as a reactant, rather here it will act as a catalyst and it will speed up the formation of ammonia. Got it? So here we are talking about the catalyst, and catalyst is a substance which speed up a chemical reaction without participating in the reaction. And here we have taken the example of sodium, nitrogen and hydrogen to form ammonia, and here also I have written the equation for that. Okay, so here these are some of the conditions which are necessary for a chemical reaction. And again remember, all the condition they are not same for all the reaction. Different reactants need different conditions, and some of the example we have discussed, there are again so many equations that we have to read later on. And again I am saying, do not have a confusion on the equation part. Here this is called the Ward equation and this is called as the chemical equation. Ward equation, chemical equation. Here I am writing both the Ward and chemical. I have written both the Ward and chemical equation so that you will be acquainted with it, and later after this topic we will discuss about chemical equation. As we have already discussed about the naming, symbol, compound and all, that's why you will not find more difficulty in finding the chemical equation. See, as here I have written sodium chloride, means you know the formula for sodium chloride, NaCl. Lead nitrate, PbNO3. Lead chloride, PbCl2 and all. And how we will write it, how we will balance it, that detail we will discuss in the chemical equation part. Do not have more confusion, just note down the equations, it will be helpful for you. Okay, and again go through your book. Again, if you will find some more equations or more examples related to it, you can share with me, and if any more doubts you got, then also you can ask me. Okay, so in the next class we will move on to the next topic, and there we will have some more discussions on a new interesting topic. And remember, don't just skip the topic, don't just